Something passed through our solar system last year that should not have been possible. Not science fiction, not a theory. A confirmed, tracked, photographed object, moving faster than anything our solar system has ever produced on a path that no comet, no asteroid, no piece of rock born here could ever follow. NASA called it 3I Atlas. For 72 hours in October, it came close enough to Mars that 3 separate spacecraft turned their cameras toward it in what insiders are now calling one of the most quietly intense observation scrambles in modern space history. What the James Webb Space Telescope found in its chemistry has scientists divided into 2 camps. One says it's the oldest comet ever seen. The other says something about its behavior doesn't add up. And one Harvard astrophysicist is saying something far more unsettling. This is the story they didn't slow down to explain to you. So let's start from the beginning, because what happened next changed how we look at the sky forever. It begins on the 1st of July, 2025, with a telescope in the mountains of Chile that wasn't even built to find this. The Atlas Survey System, Asteroid Terrestrial Impact Last Alert System, exists for one job, catching things that could hit Earth before they do. It scans the sky every night, hunting for faint moving dots that don't belong. And on that night, it caught one. At first glance, nothing special. A speck of light drifting against a field of stars, 410 million miles from the sun, somewhere out past the orbit of Jupiter. But here's where it gets interesting. When astronomers ran the numbers on its path, the math broke the rules. This object wasn't orbiting the sun, it was passing through. Its trajectory was hyperbolic, meaning it was moving too fast, on too straight a line, to ever be captured by our sun's gravity. It came from somewhere else, another star system entirely, and it was simply passing through ours like a stranger walking through a town they'll never return to. Read that again. This thing did not form here. Every planet, every moon, every asteroid, every comet in our solar system shares the same birth, the same swirling disk of dust that formed around our sun 4.6 billion years ago. This object didn't. It came from outside that family entirely. And when astronomers traced its path backward, it led not to anywhere within our solar system, but out into interstellar space itself. That made it only the 3rd object of its kind ever confirmed in human history. The first was Oumuamua in 2017, an object so strangely shaped that some scientists, including a Harvard professor named Avi Loeb, openly speculated it might not be natural at all. The second was Borisov in 2019, a more conventional-looking comet that quieted some of that speculation. Now there was a third, and this one was about to do something neither of the first 2 ever did. It was going to fly directly past one of our own planets, close enough for our own spacecraft already stationed there to watch it happen in real time. That planet was Mars. And here's where the story stops being about a distant curiosity and starts becoming something NASA had to actively respond to. As 3I Atlas approached the inner solar system, trajectory calculations showed it would pass within roughly 29 million kilometers of Mars on October the 3rd. Close enough, in astronomical terms, to be observed in genuine detail rather than as a distant smudge. Think about what that means. We already had hardware sitting on and around Mars. The Perseverance rover crawling along the rim of Jezero crater. The Mars Reconnaissance Orbiter with its powerful high-rise camera. The MAVEN spacecraft built to study the Martian atmosphere. None of these machines were designed to chase comets. They were built for a different mission entirely. But when an interstellar visitor announces it's about to fly past your front yard, you don't just keep doing what you were doing. You turn around and you look. And that's exactly what happened. In early October, mission controllers redirected instruments across multiple Mars assets toward a single point in the sky. Perseverance's Mastcam-Z captured the comet as a faint smudge against the starfield, sitting roughly 18.5 million miles from the rover at the moment of the image. The Mars Reconnaissance Orbiter's high-rise camera, an instrument so powerful it can usually resolve features on the Martian surface the size of a dinner table, pointed itself instead toward open space and captured the comet from 19 million miles away. MAVEN's ultraviolet spectrograph picked up something else entirely. A faint signature of hydrogen surrounding the comet, distinguishable from the hydrogen naturally drifting from Mars itself. 3 different machines, 3 different instruments, all built for entirely different jobs, all turning toward the same fleeting visitor in the same handful of days. Now, this is not coincidence. This is what happens when an opportunity like this comes once in a generation, and nobody wants to be the agency that missed it. But here's where the story escalates beyond Mars. Because while the Mars spacecraft were getting the closest look anyone would ever get, a much larger machine was being prepared for something even more revealing: the James Webb Space Telescope. Webb wasn't just going to take a picture, it was going to look at the comet's chemistry. Every comet that has ever drifted through our solar system carries a kind of fingerprint, a unique mixture of gases boiling off its surface as the sun's heat warms it: water vapor, carbon monoxide, carbon dioxide. The ratio between these gases tells you something profound. what kind of star system this object was born in, how cold its birthplace was, how old it might be. And when Webb turned its near-infrared spectrograph toward a 3-eye atlas, the readings that came back didn't match anything astronomers expected. The comet's coma, the glowing halo of gas and dust surrounding its icy core, was unusually rich in carbon dioxide, not a small difference. A ratio strange enough that NASA researchers, led by scientist Martin Cordner, found themselves facing two competing explanations, and neither one was simple. One possibility: the comet's nucleus itself is genuinely loaded with carbon dioxide ice, suggesting it formed somewhere far colder, far more radiation exposed than anything in our own solar system's history, possibly near the carbon dioxide frost line of a completely different star's planet-forming disk. The other possibility is stranger still. Maybe the comet does have plenty of water ice underneath, but it's sealed beneath a crust so thick and so insulating that the water simply can't escape yet. Which means what we're seeing on the surface might be hiding something completely different underneath. Either way, the implication is the same. This object may be one of the oldest things ever observed up close by human instruments, potentially 3 billion years older than our own solar system, which is itself 4.6 billion years old. Sit with that for a second. This is a piece of another star system's childhood, drifting past our own front door, older than almost everything we have ever directly touched with our science. And this is where most of the story would normally end. A fascinating ancient visitor, studied, admired, and watched as it leaves. But it didn't end there. Because somewhere in the data, something started to look less like coincidence and more like pattern. The trajectory of 3-eye Atlas, when mapped out, was tilted almost perfectly in line with the orbital plane of our planets, within about 5 degrees of the ecliptic, the imaginary flat disk that the Sun, Earth, Mars, Jupiter, and the rest all roughly orbit along. Astrophysicists calculated the odds of a random interstellar object arriving on a path that closely aligned by pure chance at somewhere around 0.2%. Think about what that means. An object born outside our solar system, flung across interstellar space for what may be billions of years, just happened to arrive on a path nearly matching the orbital plane of our planets. A plane that, on the scale of the galaxy, is tilted roughly 60 degrees away from the disk of the Milky Way itself. The odds didn't sit comfortably with everyone. This is where the story splits. On one side, the overwhelming majority of astronomers point to something simpler. Comets are not perfectly random. Interstellar objects passing near a star system are subject to gravitational nudging, and a single coincidence, however striking, does not require an exotic explanation. On the other side stood Avi Loeb, the Harvard astrophysicist, who had already raised eyebrows with his theories about Oumuamua back in 2017. Loeb didn't stop at the trajectory. He pointed to the comet's closest approach distances, about 29 million kilometers from Mars, and roughly 54 million kilometers from Jupiter during its later flyby in March 2026, and argued the timing looked almost too precise, as if the comet's arrival had been calculated to pass close to 2 major planets while staying unobservable from Earth during its closest approach to the Sun. He went further still, pointing to faint, repeating brightness patterns, some described as a kind of 16-hour heartbeat, and to traces of organic molecules, methane among them, detected in the comet's gas plume after it rounded the Sun. Organic molecules that, to survive a journey lasting potentially billions of years through the radiation of interstellar space, would need to have been buried under a protective layer of material at least 10 meters thick. Loeb raised, carefully and controversially, the question very few scientists are willing to say out loud on camera. Could an object like this be artificial? Most of the scientific community pushed back hard. The vast majority of researchers studying 3-eye Atlas describe it as exactly what it appears to be on its surface: a comet. An ancient, chemically unusual, scientifically priceless comet, but a comet nonetheless, behaving according to known physics, even where that physics produces surprising results. The real story is not that scientists have confirmed anything sinister. The real story is that, even now, with some of the most advanced instruments humanity has ever built trained directly on this object, there are details that remain genuinely, professionally unresolved. And what most people are not seeing is just how unprecedented the scale of the response actually was. This wasn't one telescope quietly logging data in the background. NASA mobilized what insiders within the agency have described as an unprecedented solar system-wide observation campaign. 12 separate NASA assets turned their instruments toward this single object during its passage: the Hubble Space Telescope, the James Webb Space Telescope. The test planet-hunting satellite, normally occupied scanning distant stars for the dim flickers of orbiting exoplanets, was redirected for a special observation run purely to study this comet's rotation and activity. The Swift Observatory, SphereX, an infrared mission barely months into its own operational life, spent roughly a week collecting data on the comet's chemical signature. The Parker Solar Probe, a spacecraft built to fly closer to the sun than any human-made object in history, offered a unique vantage point as the comet swept past. Even the Europa Clipper, a billion-dollar mission built specifically to study one of Jupiter's icy moons in search of conditions for life, found itself, for a window of days at the end of October, potentially passing directly through the ion tail of an interstellar comet, with scientists scrambling to see if its instruments could detect the telltale signature. And beyond NASA, the European Space Agency turned its own Mars orbiters, ExoMars, Trace Gas Orbiter, and Mars Express, directly at the comet during its closest pass, capturing it as nothing more than a faint, fuzzy white dot crawling across frames meant to photograph the Martian surface just a few hundred kilometers below. Two cameras, designed for a completely different kind of close-up, instead caught a visitor from another star. This is not a minor science story buried in a press release. This is what it looks like when one of the largest, most sophisticated scientific infrastructures ever built by a species turns, almost in unison, toward a single point of light streaking through the dark. Because nobody knew exactly what they would find, and nobody wanted to miss the chance to find out. But here's where it gets worse for anyone hoping for a simple, tidy resolution. The comet did not behave the way comets are supposed to behave in every respect. As it moved away from the sun after its closest approach in late October, astronomers tracking its path noticed something, a small but measurable non-gravitational acceleration. In plain terms, the comet sped up and shifted its course slightly more than gravity alone could explain. For ordinary comets, this isn't actually mysterious. It happens when sunlight heats ice on one side of a nucleus, causing jets of gas to erupt and push the object slightly off its expected path, the same way a tiny rocket thruster would. Images released by NASA in late November appeared to support exactly that explanation, showing what looked like spiraling jets erupting from the comet's surface, structures some researchers nicknamed ice volcanoes. Mainstream scientists viewed this as confirmation of perfectly natural cometary behavior. Loeb and a small number of others viewed the same images and asked whether the precision and structure of those jets was a little too clean, a little too directional, to be entirely explained by random outgassing. Two interpretations of the exact same photograph. This is the kind of disagreement that does not get resolved in a press conference. It gets resolved over years, through additional data, through other instruments, through patient analysis, long after the comet itself has vanished from view. And vanish it has. By March of 2026, 3I Atlas swept past Jupiter at a distance of roughly 53 million kilometers, a distance Loeb and others noted sat almost exactly at the edge of Jupiter's gravitational sphere of influence, its so-called Hill radius. The Juno spacecraft, already in orbit around Jupiter but critically low on fuel with known engine issues, was considered as a possible observer but ultimately could not be safely redirected. The European JUICE spacecraft, en route to Jupiter's icy moons, managed a brief glimpse instead, downloading a partial image that revealed an active comet with a visible tail before the rest of its observational data trickled in months later. And then, having swept past the only two planets close enough to offer a real look, the object simply kept going, outward, away, following the same hyperbolic path that brought it in, fading with every passing week, until by the spring of 2026 it sat more than 1 billion kilometers away, nearly 7 times the distance between Earth and the Sun, a dimming point of light heading back out into the dark between the stars, where it had come from, and where, statistically, almost nothing built by humanity will ever follow it. Think about what that actually means. We had a matter of months, a handful of months, to point every instrument we could manage at an object that took, by some estimates, billions of years to arrive, and will take billions more before anything remotely similar drifts close enough to study again. And in that brief window, we learned that this comet's nucleus might be among the oldest objects ever directly observed by human science. We learned its chemistry doesn't perfectly resemble anything born in our own solar system. We learned its trajectory carries odds against random chance significant enough that a respected astrophysicist felt compelled to raise the possibility, controversial, unproven, but raised nonetheless, that something about its arrival might not be entirely natural. And we learned, perhaps most importantly of all, that we are still not fully prepared for what happens when something like this shows up with so little warning. Because here is the part of this story that mainstream coverage rushed past. 3I Atlas was discovered only days before it became observable, and astronomers had only months, not years, to mobilize a response. The next interstellar visitor might give us even less warning. The Vera C. Rubin Observatory, recently brought online with one of the most powerful sky survey cameras ever constructed, is expected to dramatically increase how many of these objects we detect in the years ahead, potentially finding several more within a single decade, where in the past we found exactly 2 in nearly a decade between Oumuamua and Borisov, and now a third within just a few years after that. What that means is this: 3I Atlas is very likely not a once-in-a-generation event. It may be the first of many, the opening case study for an era in which interstellar visitors stop being a rarity and start becoming a recurring, almost routine part of how we watch the sky. And that raises questions nobody in the official briefings wants to answer with full confidence yet. If the next interstellar object arrives with even less warning than this one did, will our spacecraft be positioned to respond in time? Or will we be left analyzing photographs taken from tens of millions of miles away and arguing about jets and trajectories for years afterward, the way we are right now? If the unresolved chemistry of 3I Atlas, the strange carbon dioxide ratios, the buried organic molecules, the precision of its planetary flybys, turns out to have a perfectly mundane explanation, will we ever know it for certain? Or will it join Oumuamua as another visitor that left more questions than answers in its wake? And if, against the overwhelming weight of scientific consensus, even a fraction of Avi Loeb's more provocative speculation turns out to hold any truth at all, what does that mean for how we plan to greet whatever interstellar object number 4 turns out to be? Nobody has those answers yet. The James Webb Space Telescope captured chemistry that rewrote what we thought we knew about how old a visiting comet could be. NASA mobilized 12 spacecraft in a matter of weeks for an object that gave us almost no warning it was coming. And somewhere out past the orbit of Jupiter right now, fading into the dark it came from, an object older than our solar system itself is carrying its unresolved questions back out into interstellar space, leaving us, once again, exactly where we started. Watching? Waiting? And wondering what or who might be looking back the next time something like this decides to pass through our front yard.